Hi, welcome back from the summer. This is just a quick review video of how to use RoboitC as you get back into the FTC season. Once you've opened the program, one of the first things you want to do is go to Robots, and under this, make sure that your platform type has both LEGO Mindstorms NXT and Tetrix listed. You also want to go to Window, and at Menu Help, make sure you've selected Expert. You don't have to be an expert to do this, but it gives you a lot more options. The other thing you're going to want to do is go to File. You could open New, but remember that you have a whole bunch of sample programs here. And if you've forgotten a lot over the summer, which I tend to do, you can take any one of these samples. These are for First Tech Challenge specifically, but maybe you're just getting back into the swing of things, and you just want to look at maybe some NXT motor examples. Those are pretty easy. Nice way to come back in the fall. So I open that, and I'm going to do a simple moving forward and then backward. And as usual, we wait just a little bit. This gives you a little bit of comment up here. You have already defined by the program, which is really nice of RoboitC. They've set up the interface and the pragma statements so that they convert all this stuff that your motor has to talk to your computer into machine language and binaries, so we don't have to type all that, and that's excellent. You can also, at this point, come down to motor and sensor setup. I didn't remember to bring home a Tetrix, so I only have a robot, regular NXT robot. But if we had a Tetrix one, you could just go to Tetrix controllers, because that's what you're going to be using most of the time, and start with the standard configuration here, which gives you one of the high-tech DC motor controllers, a server controller. Then we can go to motors. You're going to go ahead and it's going to be the 12 volt, not that you have any other choices, but you know, that's what it is. Remember that you're going to want to make one of them reversed, because those motors mirror image each other. If you have both of them checked or unchecked, then they'll be fighting against each other, because since they're mirror image, one is going forward and one is going backwards. But if you just click the reverse check mark, then that motor will reverse and the two will be in sync. They'll actually be moving in the same direction with each other. Okay, we don't have any servos right now. If we wanted to, if you did, you would come and we've been pretty much using standard servos. If you want to use a continuous rotation servo for something, check with me. That'll be great, and we'll set that up. Port 1 is reserved pretty much in the default, and that makes your life easier if you go with the default, to be where you plug in the connection for the Tetrix controller. In other words, your DC motor controller plugs into port 1. I have a couple of sensors here, so I'm actually going to set up light sensor and use that in my program. And I want reflected light because I'm going to be doing, you know, the old follow the dark line thing. And I'm going to just call it light sensor because I'm very creative like that. And, well, I might even spell it correctly when it gets to be September. I'm going to click OK. And at this point, if you scroll back up and look, your pragma configuration now includes the sensor, which we have now called light sensor. So when you are using it in your program, you will have to refer to it as light sensor. We have motor D, motor E. We could go back in and change them to left motor, right motor, but this is early in the season. I'm not going to do that to you right this moment. And then we'll come down here. And you notice they have a bunch of comments telling you about the whole program. They've already commented it for you. You start with task main. Remember, this is not a remote control one. This is just a straight out program, and we're not declaring anything, we don't have anything that has to go up here. So we start with task main in the parentheses. We have our brackets, curly brackets here. When you're typing them in, it's easiest just to go ahead and put in the bottom bracket as well down here, and then fill in the space in between. Otherwise you get, you know, that little message that tells you that you need a curly bracket. So life goes on, but it'll save you time. Motor C is set at 100% power. Motor B is set as 100% power, and it's going to go for 4 seconds. And then it's going to reverse for 4 seconds. So basically you're not getting anywhere with this. Okay, so I'm going to leave it, we're going to set it to 80 because I think we're going to go ahead later, not in this particular video, but later, and start using PID control with this. And then we'll go ahead and let it reverse. Let's not make it go back the whole time. Let's have it go back at negative 50, or at 50% in reverse, and only go 3. So we're going to end up in a different position. It's a little bit easier to see what's happening with the program. When I do that, remember to change your code to match, or sorry, your commenting to match what your code is. If you happen to be doing extensive code, I don't know if you are commenting, rather, if you want to do something that runs several lines, you can also put / asterisk at the beginning, and then all the code or comments you want, and then end it with an asterisk and a slash. That's not going to impact anything in this program because I put the comment in the comment. Okay. Well, okay. All right. So right now we have our little program. We're not using our sensor just yet. We'll get onto that in the next lesson. And I'm going to do File, Save As, because you're working from a sample program, so you have to save it with a different name and also in a different folder, because we don't have privileges to mess up the nice sample programs. That's a good thing. Okay, and because I pretty much always dump stuff on the desktop, I'm going to actually put this one, in case, I don't know if any of you will be taking this, but we have the Independent Study Robotics program, and I'll just dump it in there. I'll put it out on the conference for the team as well. Okay, at this point I can compile and download and see what I messed up on. And it's just saying the last NXT that I had connected was different from this one, and it's of course right, but that's okay. I'm still going to go ahead. Remember that once you download, you get several window options here. You could go ahead and run the program from here with this window, just general debug, but you have some other options, whoops, sorry, my bad, for debugger windows. And I need to go back, because when you make a mistake like that, it's not happy. It takes you to a different place. There we go. Okay, so we go to the debugger windows, and you can pick the NXT devices. You can pick all of these different things and have them show up for you to use as well. Okay, but you have to be in this window for that to work. Sorry. Okay, so at this point, now I will be able to see anything happening with motor A, B, and C, and you know what happens? I get caught up out of school here because I'm not on the Tetrix, so the only motors I have showing are these, and I don't have anything programmed, so oops, don't need these. But remember, you can check your PID, your speed. You can see if your sensor is doing anything. It is saying that yes, sensor port 1 has some action going, but not a whole lot else. Okay, that was just a quick review, and this is probably too long a video, so if you quit early, that was actually a good thing. Thanks.